Okay, so welcome to this presentation. We're not many. Today we're going to talk about metaprogramming, as you already know. Who am I? My name is Luca Molteni. It's written like this for those who don't speak Italian. It's written like this. And I work for this company called Red Hat. And I work on a project called Drools. You may have probably heard about it because there was already another talk in the day talking about Drools. So we're going to mix up some topics about it. So who here knows about metaprogramming? Because what happens is usually when you do something like a niche topic, everyone that comes to your room is those who already know the topic. So there are no, actually, but this time only a few of you knows about metaprogramming. So I'm going to introduce you a bit about metaprogramming. There will be no slides in this talk, so there's a big chunk of live coding. I hope you appreciate that. So what is metaprogramming? I found many definitions on the internet, from the general to the specific, and today we're going to use a specific one. So I'm going to show you the concept of metaprogramming, which I mean to use programs to generate other programs. So when you usually code a program, you do because you want to process files, you want to interact with a user, and this time instead we're going to write a program to generate another part of a program. More specifically, we're going to generate source code of other program, okay? But sometimes you may think of metaprogramming in a more larger concepts, such as I found a definition on Wikipedia and says that metaprogramming is this technique in which the program is the data of other programs. It's more general. So if you think about metaprogramming, something like modifying programs using other programs, but these are advanced concepts. Today we're only going to talk about generating program using other programs. So it's not common at all in a Java ecosystem. But it's really, really common in other ecosystems, such as Lisp. Does anyone know about Lisp? Oops. No, I don't have Lisp installed on this machine. Of course, because if you know about metaprogramming, of course you really know about Lisp. So Lisp, I'm going to introduce you Lisp, but today we're not going to talk about Lisp, because really it's really a different topic. But Lisp is a programming language. It's more like a whole different programming languages, because there are many dialects of Lisp, but they're pretty much all very similar, and they all share the very, very simple syntax. Okay, so if you haven't seen the syntax of Lisp, it's something along this line. It's a bit strange, but it's very simple. It's pretty much all of it. That's the syntax. So this is how I would write an addition in Lisp, in many Lisps, and given this syntax, we get advantages, because once the syntax is very simple, it gets far easier to generate program using the syntax, of course. So that's why metaprogramming is so common in the Lisps. Also, while using the Lisp programming language, what we get is that a specific property of the language in which the source code of a language is actually the way the language writes a literal for a data structure. I'll give you a few seconds to think about it. So basically, the source code of a program and a data structure in Lisp has the same structure, which is exactly this. So this particular property is called homoiconicity, okay, and it's very important, but today we're not going to see that. So why am I talking about homoiconicity in Lisp? Because I come from a functional programming background, and I love this kind of topics. So maybe you haven't heard about this, and maybe you get interested, and tomorrow you go and get a book about Lisp, and Lisp becomes your love in your life, something similar. Okay, so but if you used instead something like along the line of C or C++, of course you already met metaprogramming, because of course if you ever used this directive in the C, define this directive, I hope speak. So this is the preprocessor for C, and somehow it can be C like metaprogramming, because of course the preprocessor of C, what it does, when it's evaluated, it generates source code for C. Or if you ever use something like C++, there is this library, I guess it's a library because I've never used it. It's called STL. It's called Standard Template Library. This is also somehow related to metaprogramming because the template library, what it does, it at compiles time generates more code depending on what you want to do. So you may have seen already metaprogramming, but maybe you don't know. But the problem is that in the Java world, there is no common way to do metaprogramming. It's a foreign concept. So that of course doesn't mean that we cannot do metaprogramming in Java. Of course we can totally do. But there are many different ways to do that, and we need to spend some time to decide whether which one is the best. And in the end, in the Drools project, we decided to use a tool called JavaParser, and I'll talk to you about in a second. But first, before, I would like to tell you that this is not like the definitive tool to do metaprogramming in Java. There may be other ways, maybe they are better, maybe they are worse, I don't know. That's what we used in the end, okay? So let's talk a bit about Drools. So you may have heard in Mario's topic what Drools is about. Is a business rule management system, which is a very enterprise word to call a management system for rules, of course. But I like to give this definition instead, a production system, which I found on Wikipedia, which is something like a library or program that gives you some form of artificial intelligence to you. Sounds super cool, because in these days artificial intelligence is super cool. And now I can say that I work in artificial intelligence, so I'm very happy. Apart from that, of course, business rules are basically your business logic in the program written in a specific way. And this way is what we used to call the Drools rules language, which sounds like a tongue twister, but it's Drools, DRL, Drools rules language. And it's basically something like the business logic, as I've already said, something like on the line of, in Italy, you need to be 18 years old to get a driver license. And always in Italy, you need a driver license to drive a car. And hopefully, in many states, you need a driver license to drive a car. Anyway, those are two examples of rules. So basically, you write this kind of rule in a declarative fashion. So instead of writing something like ifs in your procedural program, you write just in a file of those rules in a specific syntax. And the system, the Drools framework, helps you evaluate those rules in the fastest way possible. It's based on an algorithm written in the 70s. Is that in the 70s, in the 80s, the RETI algorithm? I don't remember the story about that. Anyway, so we improved the algorithm. It's super interesting, and check it out. Of course, Drools is a very ancient Java project. I mean, it was something like 10 years old. 15 also years old. So it was written in a specific style. I mean, we used to write such Java programs 15 years ago. So it abused reflection. It was very slow. And the problem we had that most of the time, most of the things we needed to process the rules were done at startup time. Okay. So that means that when a customer of us has something like along the line of 1 million rules, because of course you use rule engines when you have so many rules. So when you have something like 1 million rules, it takes so much time to start up Drools that it was becoming a problem. So they asked us to solve this problem. So we basically came up with an idea. We basically came up with an idea of writing a DSL written in Java that could be compiled with JavaC, the compiler, to get the bytecode. And you may have already seen, because Mario already showed you, and he basically stole half of my presentation. So I didn't know that. Even if we worked together, I didn't know that. Anyway, so we have written something like a DSL that looks like this, input, and something like, and there's lambda, and whatever. So the problem is, of course, we didn't want our customer to write such language. So what we did instead is to write a compiler that takes as an input DRL files and produces as an output this DSL in Java. So we basically use metaprogramming to generate Java code. So you may call, I've called this program a compiler, but there is a neologism that is something like a transpiler. You may have heard of it. And but one colleague of mine told me that actually transpiler is just a strange way to call compiler, because transpiler are just compilers. Anyway, so we wrote this compiler, and now we have all the Drools rules are compiled to a Java DSL that gets compiled to bytecode, and it's super fast and it's super easy and it's wonderful. And then the whole Quarkus thing came, and then we decided to launch this project called Cogito. Where's the camera? Is that the one? Is that the one? So can you see the? Can you see if you? No. So this is this is the Cogito project. Sorry, which is basically Drools running on Quarkus, and it works perfectly because, of course, once we had everything compiled, we could use Drools, our rules we could use on Quarkus, on Graal VM, and stuff like that, and it's super fast and super easy and super wonderful. And so enough of advertisement for our project. So let's see what JavaParser. In the end, we decided to use this JavaParser tool, which of course has a strange name because it's called JavaParser, so it's not called Java Metaprogrammer. But if you think about it, it makes sense. So obviously, it started as a parser for the Java programming language, but in the end, it became something along the line of a set of utilities to transform Java code, parse Java code, and generate or emit Java code. And it's super cool. Go check it out. But enough of talking, let's show you some code. Today we're going to use this thing, which is called JShell. Who knows JShell? So, come on. You don't know JShell? It's another colleague of mine, so that's why it's not a random stranger. I'm just addressing. It's not a random stranger I'm just addressing. Anyway, a JShell is a Java implementation of a REPL, which stands for read, evaluate, print, and loop. So basically, it reads my input, it evaluates against the context, it prints the result, and then loop again. So basically, if I write something like 2, it says me 2. If I write something like 2 plus 2, it gives me 4. Is that easy? Okay, so enough. Let's try something more complicated. So it can also evaluate side effects. Oops. Of course, if it's written in Java correctly. So this is a side effect. I'm printing to console. If I'm printing, it prints the output. Do you like it? Okay. So if everything is clear, let's try to get a bit more meta inside. And let's try and get a bit philosophical and think about our source code. What is source code? What is the source code of a program? I'm asking you, actually, because I don't know. No, I'm just kidding. Does anybody want to give me their interpretation? Of what? The AST. Another? A stream of token. Nice question, not yours. What about another answer, please? Not from my colleagues, please. Sylvain is not my colleague, so... What is source code? Come on, guys. Do you write source code every day? So according to Wikipedia, I have the definition in my notes. But now they're in Italian, so I cannot read. Okay, so a formal specification. So according to Wikipedia, source code is some kind of program written. I'm sorry. Let's take the definition. It's a collection of text written in a programming language, usually plain text. Okay. So whether we decide to write source code in files or maybe to store in database, think of Git, we like to think about a source code as just plain text, or maybe in Java strings. So if I want to, okay, so let me do something like this. Okay, this is JShell. So as I showed you, it can also evaluate side effect, and one of the side effects could be to define an actual method. Okay. So if I define a method in JShell, what I can do after is just call the method, and the method will get me the result, right? But what if I would like to generate a method that returns the source code of a method. What do? Metaprogramming. I do something along this line, right? Oh. Oops. Shh. Shh. Don't spoil it. Return hello world. So, does this work? No, of course. Does anybody else knows why it's not working? It's written, yes, it's written. I wish I would hide it. No, seriously. I can't hear you, I'm sorry. Okay, because of quoting, okay, right, of quotes. Because I have to tell somehow my to the Java programming language that my code inside a string, the string literal inside the code, inside a string of my methods are actually string literals. And I'm actually string literals in the code that I'm going to generate, and not instead string literals in the code. Otherwise, so it will be something like along this line, right? So if I quoted the string literals here, what I'm getting is a method called metaprogramming that returns the source code of a program. Metaprogramming. Okay, does this make sense? You may have heard of quoting. If you ever use something like XML, sometimes it's called escaping, but it's basically the same thing. It's bringing your source code to a different meta level. It's quoting. And the opposite of a dual of quoting is called evaluate. And it's same evaluate in the REPL. So read, evaluate, print loop. It means take the source code and evaluate against the context. Any questions? Just interrupt me if you have any question. Don't wait until the end. Okay? So the problem, now we have our metaprogramming, and I would have liked to use JShell for the whole presentation. But the problem is I didn't find a way to evaluate. Is there a way? No, I don't think so. No, I haven't found it. Okay, now, don't spoil the whole presentation, please. No, I'm not sorry. Now, I asked if there was a way to evaluate code in JShell, but there isn't apparently. So what I would need here is to have something like a method called eval that takes the actual method as metaprogramming and evaluate, but there is no such thing. So what I did instead, as Sylvain totally spoiled my presentation at all, so we're going to fire him, even if it's not our colleague, is to use JShell as a library in another program that I've written in Java. I'll show you in a minute. I wonder why I haven't fired idea before. I'm sorry. So what happened here, let's see if it works, this. How do you say it in English? The good things about being, whatever. I will find it. This is recorded. Anyway, what I did is just, I've written something like on the line, a really simple Java program in the idea, and I'm targeting the Java 11 because of course it's the first release that has the JShell. And what I did is I've written a simple way to use JShell as a library. So basically, I instantiate a new JShell, and then I've written an eval method, actually eval method, that takes the string as an input and actually evaluates against the context. So how do I use that? So when I can use example JShell eval like 2, and I need to get a new computer. So please ask my company to get me a new computer, hopefully a Mac. And oh my god, this is recorded. Anyway, my manager will see this. Anyway, so if I write some input here in eval, of course it evaluates. Can you see this? Okay. So let's try with the example before. So I need to generate this method greetings, which does something like I'm on the line of hello plus name, maybe with a space, right? So I want to evaluate this. But this basically what it does. If I give him the name, I say hello name. So what I will be doing is like something generate greetings, something about the line, and I wrote, okay, so greetings. So let's try the example before. Ha. Do you like it? So this is how one of my colleagues, I won't say the name, but you can imagine, writes code. I'm sorry. Generate greetings. So what I'm doing now is I'm basically to JShell to evaluate the generate greetings method, and this will evaluate the method, generate the source code, put it in the context, define the method, and after that I'm going to call the method, which is called greetings, and something along the line of Luca. What do you think? Will this work? Come on. Yes? No? Hello, Luca. Yes, it worked. No. Why did you say no? It worked. Totally worked. I tried it at home, you know. I'm sorry? Yeah, it works. It totally works. So, do you like this? Okay. Do you feel like you're doing metaprogramming? Because you're actually doing. So let's try to complicate this a little bit. We want to generate two kinds of this method. One is more formal, and the one is more like rude. So the first one would be something along the line of Boolean formal. And if it says formal, it would be good morning. Morning. And instead, if it's not formal, it will say hello. But I don't want to generate this actual method. I want to do something different. I want to generate, depending on a parameter, I want to generate two kinds of method. So once I want to generate good morning, and once I want to generate hello, depending. So I'm not putting the parameter on the actual method. I'm putting the parameter on the method that will generate the method. Is this enough method for you? Because it's getting more complicated. So something along the line of parameter, hello, no, what was? Good morning and hello. Does this work? Come on, come on, come on. You have 10 seconds. 1, 2, get a present.
Don't need the boolean in both places, right?
I'm sorry, I didn't hear anything. So you have 10 seconds. You get a present if you say to me if it works or not. Yes. Yes, I'm missing the quotes. Let's see what happens. You see the presentation? No, I'm missing the parameter. I'm just kidding. I'm just kidding. Sorry. So it totally didn't work, of course. So what happened? What happened is actually, look at the code we're generating here. We're generating a code that is totally wrong Java, because it's written something like, I don't know, it doesn't have the quotes for the string. But that's the whole point of what I'm trying to say. It's really hard to understand from this method if this method is generating the correct code or not, without actually running and maybe writing a test on it. So the correct method from this, and now I don't want to, it would be hard, but.
Sorry, Luca, but except for escaping, why did you add the boolean to both methods? Because you generate the...
No, I didn't. Look at, so now it worked. No, I didn't. Sorry, Mario. I didn't add the Boolean parameter to the actual method, which is this. I acted the Boolean parameter. No, this was an example. Yeah.
Okay.
This is another meta level. You're not on enough meta levels. You need to be different meta levels at the same times. So that's the whole problem with metaprogramming. It's really hard to understand. That's actually the point. It sounded like a joke, but it's actually the point. Every time you write about metaprogramming, you need to be at different meta levels. You always have to wonder, I'm working at this meta level, another meta level. I'm writing a string to generate a string, or to generate the literal string that will be generated. And take a look at this. This is the worst one, the plus sign. We have a plus sign here, which is white, and a plus here, which is green. That means that this is the plus that we concatenate the string in the method that will generate the method. And instead, the plus in green will be the actual plus that will be generated in method. Of course, you see where I'm getting. Okay, it's really, 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 really complicated. And also, it's really unmaintainable. When you start writing code like this, maybe at first it works. And maybe your colleagues say, okay, I did it on Christmas, and it worked. But of course, after a few months, you have to change this code, and you don't understand what it's doing. And the only way to understand what it's actually doing is to execute the code and see the printing, as what we did before. Okay, are you following me? So, by the way, this is working. It says, good morning, Luca. And of course, if I say false, it will generate a different method, which say hello name. And then I pass Luca, and it will say hello, Luca. Does it make sense? Any question? No, that's great. So let me see what I'm going to talk to you about. I totally forgot. Okay, so let's try and write this method in another way. So the method that will generate the method. I try to write in a different way, like using JavaParser. Greetings using JP. Okay, I'm going to, you have to follow me a little bit about it because it won't be easy. Ooh, I'm going to take notes here because, of course, I wasn't expecting this. I don't want to write the wrong method, I'm sorry. So, there's going to be something like a return statement, which of course stands for this return. So here you have something like the actual blueprint of what we're going to implement, something like along this line. Okay, good morning. Well, let's skip this one. Hello name. Okay, so this is a return statement in JavaParser world. So we're also going to have a binary expression. A binary expression is something along the line of you have a left expression, a right expression, an operator, which is of course this thing. In this case, the left expression will be a string literal. Hello, space. The right expression would be, in this case, would be a name exp. It's called just name exp. And will be name. And the operator will be plus. Yes, exactly. So what we're doing here, it's to generating a binary expression. So let me see, expression. Then we're going to put the actual expression as inside, of course, the return statement, because that's a statement. And then what we are going to do is to create a new method declaration, which will be public, sorry, modify. I need to get faster. This is something like the first time that I do live programming in a conference, so please be kind to me. Very kind. So we need a type. I'll write it later, and then the method will be greetings, right? Am I right? Greetings method. Nice, nice, nice. It's a very nice idea. Thank you. So the type will be something like type. Not is something like static JavaParser parse type. It will be Java lang string. Is this correct? Are there any questions about this? Let me see if I'm forgetting something. So the method will have a parameter, which will be something like string type, and I call type, and it's called name, right? I'm sorry, I'm not copying. I assure you, I prepared this. And let me see, in greetings method, that's the only slow part. So I'm sorry. Return statement. Return method. Greetings method to string. Does this work? No, of course it doesn't compile. Because you need the block statement. So the frustration is real here. Why say I need? I'm just going to say a bad word, but since it's recorded. So, I'm generate the greeting using JP. Let's see, does this work? Of course, you can't know that, but I'm pretty sure it will work at the first time. Hey, you see the difference? It worked at the first time. So, and if I, yes, try this at home. So, and let's try to do the same edit that we did before, is trying to implement the formal version when using the parameters. So this gets super easy, because if I extract this variable, say something like among the line of parameter, good morning, or hello, or maybe something like greet, good morning, hello. So now if I generate the greeting using JavaParser, it would say, good morning, Luca. What do you think? Any opinions about this? Because we discussed it about a lot at our company, and it's obviously more complicated than before. Of course, this was really easy to understand. It was a string, maybe hard to change, but really to understand. This, instead, it's really hard to write, but it's easy to change. And it's always a compromise among these two things. Okay? And, but I would like to get even a bit more philosophical in here. And I would like to, do you remember when I asked you what is source code? And we answered together something like source code is plain text. But this is source code, and this is not plain text. This is more like an AST. So source code in our brains, just try to get more philosophical, it has at the same time two different things. It's both plain text, because we read source code as plain text, and at the same time is an AST. Do you know what an AST is? It stands for abstract syntax tree, basically a tree of expression, of expression, let's say, for simplicity. So it's something among the lines of the light, that is at the same time a particle and a wave. What do you think? Do you like the analogy?
Well,
Is this mind-blowing?
I think that in reality you never read the source code like plain text, like,
Okay.
like a novel, I mean, because it becomes an AST in your mind while you are reading it. Or
Okay. So Mario is saying, you never read source code as actually plain text. You always read source code as an AST, because, and this is typical of Java programmers, when instead if you had written something like more a dynamic language, that is more typical to write source code and think about it as actual plain text. When instead, when we code Java, we have all these kind of refactoring tools, extract method, the one that I used in this presentation. And we like to think as source code as an AST, because of course what we do is let's extract a method, extract a variable, introduce a parameter, something like that, because we think source code as an AST. But maybe someone is different and thinks of source code, and if you think about source code as an AST, why do you metaprogram using plain text strings?
because it was it's a different story.
Anyway, that's not the only way we can generate code using JavaParser. That's just a way, one single way. Okay, let's try to see another one, which is, I think, more interesting. Let's try and do generics. Do you like generics? So do you like, do you know Go, the Go programming language? So apparently the Go programming language doesn't have generics. They have it now. Ah, okay. So they don't. So what I'm writing here is the typical accumulate function, or sum or fold, or whatever you want to call it. Do you like this function? Is this good? Does this work? I don't know. I'm not going to try it. But let's try to produce a method that produces this function, or this method. So string, because of course we're generating source code, and generate accumulate, something along this line. Let's do the Mario way. Sorry, Mario, this is now your way. So we're going to use generate accumulate. Of course, it doesn't take parameters. And then we're going to call the accumulate function. Oh my God. It's only 10 minutes left. Something like along the line of this. I'm sorry. I got distracted by the room manager. Value 6. Yes! First time. So, now what happens? Now the customer comes to you and says something like, "Oh no, I was wrong. I didn't want to some integers. I wanted to some doubles." So what do? You do something like this, right? Replace. Yeah, it worked. Does this work? 10 seconds. Does it work? It may. That's a great answer. It worked the first time. So then the customer comes to you and say, no, I was wrong. It was integers. I say, how come? One day is integer, one day is double. It depends on the customer, he says. Okay, it depends. So what we do, because we are lazy, we don't want to, do not repeat yourself, you used to say. We do something like I'm on this line, num type, and we replace the actual double. This is hard, so I'm sorry. Num type plus like this. Okay, does this work? Yeah, I heard a yes. Let me see. What do you think, Machai? Does this work? No, it doesn't. It worked. So if I wanted instead the integer version, it worked. Hopefully. Ta-da, value 6, so it's perfect. And as you can see, this code is already unreadable. You have to think about white space for the very same reasons as before. So we try to see a different way, and we try to see a way that uses, of course, JavaParser, but it doesn't use the DSL of JavaParsers, which we discussed is not that clear, actually. Using JavaParser, let me see. So what we're going to do is to keep the clarity of the string, something among this line, and instead of replacing the integer with a string, we're going to replace with something like a placeholder, right? And then what we're going to do is to check my notes, because I don't remember. I'm sorry, guys. I should have tried this at home like so many times, but since I switched to English, I forgot all the code. So there's body declaration. It would be something like static JavaParser parse body declaration. So that's code. Well, what we're going to do now is to use another utility of JavaParser to actually transform this source code, which is, again, metaprogramming. So we're going to find all the type classes. Is it type classes, right? That takes a lambda. It says something like num type equals t a string. And for each of these, we're going to replace this with static JavaParser, parse type, will be num type. And then we're going to return. Do you like it?
Or you can write a regular expression that
I could, yes. Let's wait for question. So it worked the first time. So that, and of course, if I substitute the type, I get a different version at using the doubles. Okay, and it worked the first time. So we have something like among the line the best of two worlds, because we have the clarity of having the code written in an explicit way in a string. It's somehow easy to read. And at the same time, we get to replace the placeholder inside the code using a DSL, using a set of utilities with JavaParser. And we can do even better. What we can do, instead of putting the code in a string, we can put the source code in a Java file that is in the resource folder. It's important that you put it in the resource folder, otherwise it will get compiled, and you don't want to get compiled because this is not actually Java code, not valid Java code. And then parse it, and let me see if I can If you want, I'll show you the API, but of course the API is just a detail. So what do you think? If you want, I'll show you the API, but it's just the details. It's even faster. We should have 5 minutes, right? So I'm sorry, I skipped a bit. What do you think? Is this more clear? Do you think it's clearer to write program uses strings? Yes? No? Any question? Yes, question.
If I wanted to add leaf clause like in the other example. So for instance, you use the body declaration and
Yes.
you add a replacement.
Yes.
But it's possible in a similar fashion to add a leaf clause, for instance.
Yeah, sure. JavaParser support all the Java syntax specifications, so you basically generate whatever you want. Of course, for each kind of what you want, for example, in your case, you wanted an if statement. In Java, ifs are statement and not expression, so it's pretty important to understand because, of course, you have to remember the name of a class. So if you search for if expression, you won't find it. Then if you remember that if is a statement, then you see that there is an if statement. So basically, you can generate whatever you want. And the nice part about it is that obviously this DSL is type safe. So basically you can generate not valid Java code, of course, using a DSL, but it's more difficult. Okay? I'm sorry, did I answer your question? Okay. So if I want, I can show you the API to generate if statement. But
In the first example,
yes.
it's possible to parse a method that is in the scope, get the AST, and modify that AST later. Like for example, the greetings. Let's say we
Yes.
get parse
Yes.
the method here, I get the AST, and you could have like maybe the if parameter to change the AST in some
Yes. So you're asking me if we can change the first example in which we take the greetings method and parse the AST and modify the AST using JavaParser. Yes, of course you can do that. You can parse whatever Java source code you can. JavaParser is used for many refactoring tools for do something like change name of the variables in a type safe way. You have so many options with JavaParser. It's very, very powerful. I'm not sure it's the best DSL to generate Java source code, but that's not his whole point. I mean, there are plenty of DSL to generate Java. If you find another one and you really need to only to generate Java, you can choose another one. That's not the point. I'm not telling you just use JavaParser. What I'm showing to you is that JavaParser is really powerful, and these are pretty much the feature. So, yes,
something completely useless.
yes.
Do you know queens, QUINs?
Do I know Queens? No, I'm not sure.
It's another metaprogramming useless thing, which it's a program that generates itself.
Ah, okay, that's very cool.
The exact source code
Okay.
itself.
So he showed us the name of a program that generates itself, which of course is a more advanced topic of metaprogramming, and it's super cool. And I wish I could show you something more interesting than just hello world's method, but it's like more an introductory course to metaprogramming. So, any other questions?
Can I give you, let's say, a keyword?
Yes.
Partial evaluation.
Partial
Partial evaluation.
partial evaluation.
Don't you think that basically most of these examples could be resolved using partial evaluation?
So Sylvain is asking me if whether this could be used during currying or at least partial evaluation.
No, what I'm talking about is, for example, you create a method, hello, the if blah blah blah,
Yes.
return one or another.
Yes.
The problem is that you do it at runtime. But
Yes.
in theory, using partial evaluation, as you give in the input for generating one or another, statically what would be the most reduced form of this method.
So I'm
In theory,
yes.
I would guess, you could write basically normal Java code, evaluated symbolically at compile time, again, and get back what would be the most reduced form of this method.
Yeah, I'm not sure I can
I mean,
I can say the question again because
No,
it's too long. It's more like,
no,
but the answer is yes.
I would guess that,
Let's clarify the question
the generation. Let's say
You can replace the generation
whole
with
generation.
partial expression.
Partial evaluation.
A partial evaluation.
I would guess, but it's only a hint. I'm not sure.
Yeah, I'm sorry. There's another question. Mario, I'm sorry. Ah, okay, it's this one.
This API was familiar to me, and
Ah,
I remember.
that's perfect.
It's essentially when you try to do a plugin for the Java C compiler,
Mm-hmm.
when you generate code, it's exactly very similar.
Oh, that's nice.
It's exactly, you can write the same code to like intercept like at a certain moment the compilation, rewrite whatever you want, and then it would get, you know, the compiled stuff.
Yeah, it's basically what we're trying to do with Cogito, because the reason why we decided to go this way is, of course, that once you're using ahead of time compilation, you need to have everything compiled before, because of course on the Graal VM, I'm not sure if this is somehow related, maybe not related to yours, but yes.
It's what's called the Futamura projection.
Is it? Okay. I didn't know that. I'm sorry. So when you use ahead of time compilation, you need to have basically everything compiled. So what we decided to do is to generate all the parts of the code that we needed before. So what we'll have is that at compile time, we register something like a piece of program that actually takes as an input a DRL file and emits more program, just like just like a plugin for Java C or something like a preprocessor or something similar. And you can do a whole lot of things, and it's super interesting and super powerful. And of course, only your imagination is the limit. How's that? So if there aren't any other questions, I will close this here. Thank you for coming.